Hi, everyone. Welcome to this week's Isaac ROS Office Hours. My name is Asavari, and I'm a technical marketing engineer at NVIDIA, working on robotics on our Jetson platform. Today, we'll be talking briefly about Nvblox, an Isaac ROS package that does 3D scene reconstruction and mapping for navigation. This will be followed by our question and answer session, where you can ask all your Isaac ROS related questions, and my colleague and I will try our best to answer them throughout the chat and towards the end of the call of this session as well. So feel free to start posting questions in the chat already. We'll pick them up as we go. Give me a minute here to share some of my slides. Okay, that's better. So let's get started. So the Isaac ROS Office Hours is something we do every other week. And in the last Isaac ROS Office Hours, we talked about the Isaac ROS Visual SLAM package. The underlying algorithm is called QV SLAM. And my colleague Raffaello explained a lot about this and some examples as well, and had a question and answer session as well. I've provided the QR code and the link on the slide here. So please go check it out, rewatch this session because we had a lot of good questions come up in that session as well. And you can always ask any Isaac ROS. It does not have to be related to the topic of the day or the agenda, but just any of the questions that maybe you've been trying some other packages with Isaac ROS, and this is the best platform to get started with asking all of your questions. Okay, so coming to today's agenda, I plan on spending some 15 minutes talking about Nvblox, the Isaac ROS Nvblox packages. So there's a collection of packages and all of their ROS parameters, the interface, and just how to use them. I'll also talk about some included examples and how you can use Nvblox with the ROS2 navigation framework called Nav2. It doesn't matter if you've used Nav2 in the past, if you have experience with it, but this is something that we have some examples right off the bat that you can get started with. And then we'll spend a remainder of the time on questions from you and just getting into more detail in case anything is unclear. Before we get started, I really encourage you to read this blog written by my colleague on simulating and localizing a Husky robot with NVIDIA Isaac Sim and NVIDIA Isaac ROS. It's a comprehensive blog explaining how to use Isaac Sim and Isaac ROS packages together to test and perform different robotic tasks. So in this particular blog, I think we talk about Isaac ROS Visual SLAM, Isaac ROS Nvblox, and another package called Isaac ROS April tags to essentially localize the robot and and create a real-time map, a 3D map. So this is a good example showing how to integrate these packages into your robot, into your navigation stack if you're already using that. Okay, so let me first talk a little bit about Nvblox, which is the underlying work to Isaac ROS Nvblox. So this is a vision-based 3D reconstruction library that generates cost maps for navigation. And it offers GPU accelerated algorithms, including TSDF and ESDF reconstruction. So before going ahead, I think it's worth talking a little bit about what TSDF and ESDF, what these terms mean. So TSDF stands for truncated signed distance fields. And this is essentially a way to represent and reconstruct 3D surfaces in robotics. It also has applications in just computer vision and graphics in general. So TSDF approaches store the distance to the closest surface at each voxel in a 3D map or in a 3D grid. So imagine a voxel as a data point in a 3D grid. And if you're interested, especially in cases like navigation, where you want to avoid collision with obstacles, it's very useful. It's essential to know distances to the nearest obstacles. Now, typically, these TSDF-based reconstructions provide very high-quality surface reconstructions. And this is what Nvblox uses. So the other term that I mentioned, ESDF, stands for Euclidean signed distance fields. ESDFs are a voxel grid where every point contains the Euclidean distance to the nearest obstacle. So that's how you can calculate during path planning what is the best path to take so that you avoid collisions with obstacles. So distance fields provide a very quick way for collision checking and are very useful in robotic path planning. Now, Nvblox outputs a 2D distance map So what it does is that it takes a slice of the 3D voxel grid that we just talked about, and that slice is a 2D distance map. So it represents the distance at each point from objects that are reconstructed in the environment. And then this is used by your planner to compute a collision cost map. So this is how both things work together in Nvblox. One is to create the 3D reconstruction, and then one is to find distances within that reconstruction to avoid collisions. Now, Nvblox, the interesting thing about Nvblox is that it's optimized to run on NVIDIA GPUs and on the NVIDIA Jetson as well. So if you have any embedded applications where you may already be using a Jetson on your robot, right? This is a great place to get started because Nvblox can run right like on the NVIDIA Jetson. And it has been integrated. So Nvblox has a ROS2 package called Isaac ROS Nvblox, which we'll get to, and which is the main point of this of today's session. But that is the ROS2 interface. So you can also just use it with your ROS-based systems. Okay, moving on to Isaac ROS Nvblox. So this contains ROS2 packages for local 3D scene reconstruction and cost maps for navigation. So it uses two things mainly, depth and pose, to reconstruct a 3D scene in real time. Now, the depth information can come from a depth camera or a 3D LiDAR, whatever you may be using on your system. And pose information can come from SLAM. In some of our examples, we've used the Isaac ROS Visual SLAM package, but if you have another SLAM node that you're using, that will suffice as well. So on the left side of the GIF here on this slide, we see a sample reconstruction of like a warehouse setting. So you see these stacks or rows of boxes. Now, Isaac ROS Nvblox also outputs a cost map. So that's the colored zones that you see at the bottom, at the ground surface over there. And that is used in path planning and obstacle avoidance during navigation. So I'll give you a quick overview of what nav2 is and what a cost map is, for those of you who may not be familiar with those terms. So nav2 is kind of the standard, it's the ROS2 navigation framework that provides perception, planning, control, localization, and everything you need to develop an autonomous system. A cost map is the representation of the current environment in the form of a 2D grid. So imagine it as a 2D grid where each cell in the grid contains a cost that represents whether the cell is empty, whether it's occupied, or whether it's unknown about the status. So cost maps are generated to detect and avoid obstacles in the environment using information from sensors like cameras or LiDARs. So for Isaac ROS Nvblox, you can use like a combination of both, or you can use just a 3D LiDAR or just a camera as well for depth images. So again, if you look at the left of the GIF here, these colored zones that show up, they'll show up in a minute, but yeah, so that is a cost map. And each color here kind of represents the occupancy status of that location or how close it is to an obstacle. So Nvblox can then be used to generate a cost map like this. And this cost map is used to plan a robot's path during navigation. So that's how it all ties in together. Isaac ROS Nvblox also has 3 modes in which it can work. So the default mode assumes a static environment where there are no moving parts or no humans. But then we have a second mode which supports human reconstruction. And this is mainly for mapping in scenes where humans are present. So it may be like a factory floor or maybe outdoors like a farm or something like that. And then the third is a general dynamic reconstruction mode. So this is for scenes that just contain moving objects, any moving object. So for a warehouse setting like this, for example, that could mean forklifts or other robots that are operating within the environment. Okay, so let's move on to an example graph or an example ROS pipeline that uses Nvblox and some of its packages. So this graph here shows Isaac ROS Nvblox in the human reconstruction mode that we talked about. So Nvblox takes, in this case, a depth image. It also takes a color image, which is optional. The color image is just for colorizing the mesh once Nvblox has output a 3D reconstruction. But the depth image is required and the pose is required. So these are the 3 inputs that you see on the graph here. So in this case, the pose is calculated using Isaac ROS Visual SLAM. But like I said, any other pose estimation node that you have can be used here as well. The input color image is first processed using a segmentation network called UNet and a trained model called People SemSegNet. So this model and network are just used to create a segmentation mask for people in the image And then Nvblox uses that generated mask to isolate people into a separate part of the reconstruction. So again, these are the unit model can be avoided if you don't want to do human reconstruction at all. In which case you would just be passing depth and pose into your into the Nvblox node. So for this reconstruction, Nvblox creates a cost map, which is provided to nav2 through a cost map plugin. So this is done by the Nvblox nav2 package over here. It's a package that contains a custom plugin through which nav2 can consume the output from Nvblox. So again, this is a package that's part of the Isaac ROS Nvblox repository. And there are multiple such like auxiliary packages which help visualize and build the whole pipeline with Nvblox. So just like that, another useful package is the Nvblox RViz plugin. So this just creates a colorized 3D mesh, which can be visualized on RViz. So Nvblox then streams these mesh updates as the map goes on changing to RViz in real time, such that the reconstruction is updated as it's built. So at any given time, you don't need to have information of the entire mesh, but just updates coming in through Nvblox, and then you can keep building upon it and then visualize it in RViz. So this was just an example overview of a graph and how it would use Isaac ROS Nvblox. And of course, you can use the different packages in Nvblox to create your own pipelines with your own nodes as well. Like in this case, pose estimation can come from your pre-existing system already. Okay, before moving on, I see a question in the chat. It says, are the models in Nvblox modular? Could I plug an arbitrary model? Yes, they are modular. So let me go back a slide. I believe by model you're talking about maybe unit as an example in the slide here. Yes, you could use your own models. You just have to make sure that the topics that are required by Nvblox, which we'll come to in a minute, like on a later slide, you just really have to make sure that those topics are available in your system and through your models, through your nodes, and then Nvblox should pretty much work. Yes. Okay, so let's move on. This is really interesting. The Nvblox repository already includes a bunch of examples running Nvblox that you can try right off the bat. So let's say, for example, if you have an Intel RealSense camera, there is an example that's available to perform reconstruction using Isaac ROS Visual SLAM and Isaac ROS Nvblox. You can also run this in the different modes that we mentioned earlier. So that would include either just the static mode or the human reconstruction mode or the general dynamic object reconstruction. Now, this tutorial also includes steps for recording RealSense data in case you want to run Nvblox on recorded data. So if there's a situation where maybe you don't want to run it live, or you have data from some other environment and you just want to test this, you can do that as well through, there's an argument that allows you to play a ROS bag and run Nvblox on topics from the ROS bag. And then next, we have a set of examples running Nvblox using simulated images and simulated LiDAR data from Isaac Sim. So of course, to be able to experiment with these examples, you'd have to install Isaac Sim first. But the 3D mesh can be visualized in RViz using the plugin that we talked about, the Nvblox RViz plugin. And it can be used to generate a cost map for nav2 as well. So again, you have separate tutorials and separate launch files and configuration files showing how to run Isaac Sim in the different Nvblox modes that we talked about. Then if you have a Z camera, there's an example showing static reconstruction using a Z camera as well. And I don't think we currently have the human reconstruction or general dynamic reconstruction example for that, but I believe you can use some of the reference files from the other examples to get that working with the Z camera as well. Okay, so let's move on to some of the parameters that you can tweak to use Nvblox with your examples. So there are some multiple parameters actually exposed to at the ROS level. Now, under the Isaac ROS Nvblox repository on GitHub, there is a package called Nvblox examples bring up. So this contains the launch files and the configuration files for all the examples we just talked about on the last slide. And parameters for these examples are set using YAML configuration files. And these are all under the config folder in the Nvblox examples bring up package. So I'd encourage you to go and check out that package on, maybe that's the first thing you should be checking out on the GitHub. And this is how it works. So the base parameters for all examples are set in a file called the nvblox base.yaml file. And then on top of that, you have multiple specialization files that kind of override the parameters from the base file based on the example that's launched. So for example, if you launch, let's say you have a RealSense camera and you've launched the reconstruction example using RealSense, then that would first set parameters through the nvblox realsense.yaml file. And then this would be on top of the base file. So you can kind of override parameters there based on your use case. Now, let's look at some of the general NVBlox parameters. On this slide, I've just provided a short list. But note that this list does not include all parameters, right? But you can find all of them on the documentation side. These are just some of the ones I thought we'd talk about today. So the first one here, the compute mesh param, is a Boolean value. So it takes a true or a false value about whether to output a mesh for visualization on RViz. So you can choose to not do this as well. But if you want like a visual output, then compute mesh has to be set to true. And this is used with the NVBlox RViz plugin we talked about earlier. Then you have the mesh update rate hertz param. This specifies the rate in hertz at which to update and publish the mesh. So I believe a higher rate would possibly result in, you'd basically need a more heavy Jetson to be able to run this because it's more compute intensive. Then let's come to the voxel size parameter. This is, as the name suggests, you can use it to set the voxel size in meters to use for the map. Then you have the use TF transforms parameter. This specifies whether to use TF transforms. So if this is set to false, NVBlox must listen to the topics for transforms, in which case you need to make sure that in your system, there are some topics that are publishing transforms, and NVBlox has to be able to listen to those. Now, the next param is the compute ESDF parameter. We talked about ESDF in an earlier slide. This takes a true or false value about whether to compute the ESDF to the nearest obstacle. So that is the map distances to the nearest obstacles. And then you have the use color, use LiDAR Boolean parameters. These two, again, as the name suggests, they help specify whether to color the mesh and whether to integrate LiDAR scans respectively. So again, colorization is optional. If this is set to true, it will color the reconstructed 3D mesh. Okay, so we have a question in the chat. It says, I'm working on UR10 and having issues to put the robot gripper with end effector in Isaac Sim. Do you have any advice for that? Okay, so this may not be the best place to, because this seems more like an Isaac Sim related question. So we do have the Isaac Sim office hours every other week as well, alternating with the Isaac ROS office hours. So the next one on Isaac Sim would be next Wednesday. I think that would be a more appropriate place to ask this question, because you can get an expert to answer it and some more details than what I can provide today. So if you're not able to join the next Isaac Sim office hours, I'd encourage you to. We have an Isaac Sim forum, developer forum as well. So that would be a good platform to post this question, because maybe someone has also experienced this problem before, and on the forum you can find a solution immediately. If not, someone will get you with the answer. And then my colleague, I believe, has also posted a reminder. We have NVIDIA GTC coming up in mid-March this year. It's both going to be in person and virtual as well. So I will share a QR code, I believe, later in my slides from where you can register. But do check it out. It would be a great place to. There we go. We have the Isaac Sim support forum link posted as well. But yeah, do register for GTC. I'll share some more information soon. Okay. So let's move on to some of the Isaac ROS Nvblox topics and services that are used by the Nvblox nodes. So I'll briefly explain each of the topics that Nvblox subscribes to, since this input information is absolutely required for Nvblox to work in your system. So first is the point cloud topic, on which a 3D LiDAR point cloud is shared. So the LiDAR intrinsics must be set if you're using this input to convert the point cloud into a depth image for use with Nvblox. Then you have the optional color topics, which include the image topic and the camera info. So these are only used to eventually color the output mesh. So they're therefore optional. If this is set to false, you don't necessarily need something publishing on these topics, but then you'll just get a 3D mesh that is not colored. Then you have the required depth topics. So that includes the image and the depth camera info topics. So this is just the input depth image and corresponding camera information topic containing the intrinsics of the depth camera. Again, here you can have for Nvblox either a 3D camera or a 3D LiDAR as well. Then you have the transform and the pose topics. So these contain the odometry as stamped transform messages and stamped pose messages, respectively. It can come from any Visual Slam node. Easiest way would be to use the Isaac ROS Visual Slam node. Now moving on to some of the topics published by the Nvblox node. This is again only a subset of all the published topics, and you can find the entire list in the documentation. But just because there are so many topics that are published, I am not going through all of them in detail. So the first is a mesh topic, which is your visualization topic, showing the mesh in a form that can be visualized in RViz using the plugin, Nvblox RViz plugin. And the update rate can be set using the mesh update rate hertz parameter that we talked about on the last slide. Then you have the static map slice parameter. This contains a 2D slice that is to be consumed by the Nvblox nav2 package for use with nav2. So a quick reminder is that the Nvblox nav2 package was the custom plugin, the custom cost map plugin that converts the output from Nvblox to a usable cost map by the nav2 framework. Then let's look at the static occupancy parameter topic. Sorry, this contains a point cloud of the static occupancy map. So only those voxels where the probability is of it being occupied is greater than 0.5 will show up with some threshold in the static occupancy topic. And then there are a couple of others as well. We can, of course, go into more detail on the documentation side. So let's talk about some of the ROS services that are provided by Nvblox. The save ply service saves the mesh in the ply format, which is a standard format, which you can later, I believe, render and view on MeshLab or something like that. So this just saves it in the specified location. The save map service serializes the entire map at the given location. And the load map service, as the name suggests, it overwrites your current map that's in the node with a map that's loaded from the specified location. So if you have saved a map of your environment using the save map service, you can also load that at the current in the current environment using load map. And so these are just some examples of the topics. There are some additional topics that are additionally used with the human reconstruction mode and the dynamic generation mode as well of Nvblox. So you can learn more about those in the documentation. Okay, I see a question. It says, struggling to understand how Visual Slam and Nvblox work together to help in AMR navigation. Both have map saving and loading services. Okay, that's a good question. Why they work together is that Nvblox requires a pose, right? It is one of the required topics that are subscribed. And that's where Visual Slam comes into the picture. Visual Slam can be used to provide that pose to Nvblox. So it's not exactly, it's not like Visual Slam and Nvblox are working in parallel or redundant. It's more like Nvblox requires the output from Visual Slam. So that's how it looks in the chain or in the ROS pipeline. Also, I believe if you are talking specifically about Isaac ROS Visual Slam here, the map saving service in Visual Slam is a little different. It kind of saves the point cloud of the map, but not an actual map that can be used with Nvblox nav2, for example. So the way or the information that is stored, although they're both called map, but it's different information that's stored by each service. Okay, we have another question saying, can you gift us with the wisdom of creating custom publisher and subscriber in code and as well custom graphs? Yes. So the best way to understand like how you can write your custom examples or publisher and subscriber would be to go to the examples I had mentioned a bit earlier. We can also go through the documentation site in a minute, and I'll show you there all the different examples that are already part of Nvblox. And those are honestly the best way to get started. Like you can just go through and run those examples even using Isaac Sim yourself. and then tweak them as you go to fit your particular use case. So that would be the best place to look at code and custom graphs as well. Okay, so let's move on. Okay, so I just wanted to share a couple of important links here. The first link is to the Isaac ROS forum, where you can view posts and questions from other developers. You can view answers that the engineering team may have already provided while resolving those questions. You can post your own questions here and get help from the engineering team as well. So you'll also, Isaac ROS forum, the first link is also the place to find all relevant resources to the documentation, to the previous office hours that we've had, and previous Isaac ROS webinars as well. So do check that out. The second link points to the NVIDIA Isaac ROS page. So that's the official website where you can find information about all the different packages, the performance numbers, all the customer stories, how they're using Isaac ROS packages, and just some of the latest Isaac ROS related news and resources as well. Okay, I see another question. It says, some robots do not use the ROS2 standard DDS. How do you deal with changes in the data? Okay, so the best way to do this is you can set, of course, I think the most easiest way is to set an environment variable to specify which middleware to use. But I think we also, with Isaac ROS, we had some issues with the standard DDS, which is why, or it was with RTPS, so we were trying to move to the other data format. But this is something that you would have to, I believe, experiment and see what works best in your case. Okay, moving on. Okay, we're almost towards the end of the slides I had prepared for today. But one last thing before we get to the Q&A, please join us for NVIDIA GTC in March this year, from March 17th to March 21st. This is an excellent opportunity to learn from industry experts about what's to come in AI and accelerated computing. So it's going to be both in person and virtual this year. And there's just a lot to gain from all the technical workshops, the networking sessions, all the different events that we have. And you can use the QR code I've shared here to register for the conference. I think there is some, I'm not sure, but there might be an early bird registration or something till the beginning of February. So yeah, I encourage you to get to it as soon as you can. Okay, so that covers the brief introduction to Isaac ROS Nvblox that I wanted to share today. Of course, it's a lot more complex than that. So I think if we have some time, and I'd also encourage you independently to go and check out our documentation site. That's the best place to get all the information and all details about it. But now we just have some time to focus on questions, and let me go through the Isaac ROS Nvblox documentation as well. Feel free to keep posting your questions in the chat. And I'm going to stop sharing for a minute so that I can share the documentation site. Okay, there we go. So this is the official Isaac ROS documentation site. It's something that it's not too new. It's maybe a month or two old, but we've also been talking about this in the previous office hour sessions. I hope you've had a chance to check it out. From here, we can go to the repositories and packages. And then let's say we're only interested today in Isaac ROS Nvblox. So let's go there. This just gives you a general overview of the Isaac ROS Nvblox package. This is the graph that we saw already. And the way we've arranged this is that if you want to go, so there are multiple Isaac ROS Nvblox packages, right? So if you want information about each of them, say we're looking at Nvblox nav2, then you can just go to that particular package on GitHub. And then on GitHub, someone in the chat had asked a question about like actual code to like the publishers and subscribers that use all these nodes. This would be the best way to do it. So here you can see the custom cost map layer as well, the custom cost map plugin, and the Isaac ROS Nvblox repo here has actual code to all of those different packages. This would be a great place to get started. Also a great place to just use as reference if you want to write your own nodes. So that was just the Nvblox nav2 package. I see a question in the chat. So let's get to that. It says, do you have any concrete examples of Isaac Cortex being used in advanced scenarios beyond simple samples available in Isaac Sim? Okay, so again, I think this question is better directed in the next Isaac Sim officers or on the Isaac Sim forum as well. Okay. So let's go to the Isaac ROS Nvblox quick start. I think that's a good place where we provide a ROS bag, so it's an easy way to just get started. Again, you have source code on GitHub. What you do here is you can, if you already have your ROS workspace, you can just clone this package over there. So that would be to the Isaac ROS common. Anyone who's already worked with the Isaac ROS workflow before knows how convenient it is to just work through the container as well. We also provide a ROS bag of sample data. So this, I believe, is data that it's simulated data from Isaac Sim. So all the topics that you need are just available there, and you don't have to run any additional, like, you don't need a physical sensor or anything like that. You can just use this ROS bag. Install all the dependencies, build your workspace, standard ROS workflow here. And then you can just launch the example through the Nvblox examples bring up package. So this package that I'm highlighting here has all the different examples that we talked about. And then one particular example that we're running here in the quick start is the Isaac Sim example launch file. So once you run that, you should see a robot like as per the image here, the robot actually reconstructs the entire mesh that it's seeing currently in the sim window. So I believe it's seeing a couple of rows of boxes, it's seeing like a forklift. All of that is generated in the form of a 3D mesh, as well as the cost map. So again, the colored zones over here show the proximity to the nearest obstacle, which is why the colors change as you get closer to the forklift and to the boxes as well. This little arrow that you see over here, the 3D axis, that is the pose, the current pose of the robot. And that information comes from the Visual Slam, Isaac ROS Visual Slam node. Okay, so I think one of the more interesting parts is all the different examples. Like there are so many that we provide already. Let's actually look at some of them. So the Isaac Sim example is the quick start one that we just saw. There is an example to run with a RealSense camera. So I'm gonna open that up. So this is a static reconstruction example with the RealSense, but there is also human reconstruction and general object reconstruction. I'm gonna let this GIF play out. I'm going to explain what it is. So the little image window at the bottom is what the RealSense camera is viewing, obviously. So you can see like a whole bunch of desks and just some objects on the desk as well, the cabinets. All of that is reconstructed and captured, I think, fairly well in the 3D mesh. And the mesh that you see in Arviz over here is visualized through the Nvblox Arviz plugin. It also creates, so you can see a sort of sparse point cloud of all the different points that it's reconstructing. So of course, for this one, you have to be using some pose estimation node as well. It's not just Nvblox alone. There is some requirements as to like the settings and intrinsics of the RealSense camera. All of that information is available in the tutorial here. And it's just a super easy way to follow. You can do two things here. You can either record the RealSense data and then play back the ROS bag and then run Nvblox on it, or you can do it live as well. So both ways of doing it, I think, are provided here. Yes, towards the end, you have an example with RealSense recorded data, and then this is the RealSense live data version as well. So this is the RealSense example. Let's go back and look at the Z camera. Here, we have an example to run with the Z camera. I'm going to let this GIF play out as well. Awesome. So again, you have depth camera based reconstruction using the Z. This is also like the two images that you see here. One is the color and the depth image. I believe color is again only used for mesh colorization. And then towards the end of the GIF, there's also the, the cost map that comes up to use with Nav2. We also have a quick way to, so because ROS message can be unreliable, so the mesh can get kind of choppy. So we have some modifications to play around with the quality of service profile. And this is how you can do that here. There is a question that says, could you actually walk through the setup process? Okay, yes, for sure. That's a good question. I think I'm assuming you mean the setup process for Nvblox specifically. So let's go through it with the quick start. I think that's the easiest, most straightforward way to do it. So first, what you have to do is there is a Isaac ROS developer environment setup. So that's step one, which I've gone to over here. What you want to do here is, it depends. You can, so you're either doing this on like an x86 machine or on the Jetson platform. We have instructions for both over here on the developer environment setup page. So what you would do is, this is like one way to do it is through the Docker container, which is very convenient. There is a developer Docker container. I would just encourage you to follow the specific steps given here. So you have to install git LFS because there are some larger files in terms of ROS bags for most of these examples. If you've worked with ROS before, you know how to create a ROS2 workspace. So you would do that, you would build it and source it. These are standard ROS workflows so far. And we do have like a troubleshooting section as well. So in case you have issues with some of the setup process, that's where you would go. There are some things you need to make sure. If you're running, say, on the Jetson, you want to make sure that there's at least 30 GBs of space because that's kind of as big as the container and data sets are right now. So I believe the Jetson Orin is capable, but then if you're using some smaller, like if you're using the Jetson Nano or NX, Xavier NX, then you would need an SSD to be able to run this. Okay, so that is step one about like how to actually set up your development environment. Once you have that set up, from step two here, this is where we come to kind of just the Isaac ROS specific setup. So here you first clone something called the Isaac ROS common repository. So this repository contains all of the base packages that you need to run most of the Isaac ROS examples. This is in fact the repository that kind of provides the script to run everything, including your container. So once that is cloned, you can clone your particular repository of choice. So if we're talking about Isaac ROS Nvblox here, you would clone that. Git LFS pull just so that you get all the ROS packs that you want to run the examples with. And step three is just pulling down the sample data. So this, like I mentioned, I believe is data that came from Isaac Sim. So you would pull down that ROS pack. In step four, you go into the Isaac ROS common repository. There is a directory named scripts over there, and from there you can run the run dev.sh script. So this script is what launches your container and sets up all the dependencies, everything within it to be able to run most examples. And then you can use in step 5 here, we're just installing some package specific dependencies using ROSDEP. So this is a fairly straightforward, like nothing can go wrong here. You just have to follow these steps to get to a point where you can start running the examples. Also, in step, I think 3 or 2 here, we pull down just the Isaac ROS Nvblox package. But of course, what you want to do is if you're running some of the other packages in Isaac ROS, some of the other workflows, then pull down all the related packages for those particular repositories. So let's see. Once you have built your workspace and sourced it, you're ready to start running some of the examples. It's honestly as easy as that. And then you can just do like a ROS2 launch the examples. So NVBlox examples bring up is the package with all the examples. So you just do a ROS tool launch and then any particular example launch file you want over there. This, of course, just launches your like the script to run the example, but there is no input data coming in yet because it does not launch the ROS bag as well. So in another terminal, all you have to do is play back the ROS bag file. So this can be either something you've used from the quick start or something you've recorded earlier yourself. But you just play that in a separate terminal. And then in another terminal, you have the actual example launch file running. And then in a third terminal, this, by the way, also launches the RViz window. So you can view it just straight up over there. But if you also want to, let's say, echo out any of the topics or like the rate you want to see at which it's being published, you can, of course, open your own third terminal and just do a ROS to topic hertz and stuff like that over there. So I hope that answers your question. Let's look at one last example. I think let's look at Isaac Sim with human reconstruction. Okay, so this is a GIF we saw earlier. You have, so on the top right here is the colored image. So this is just coming in through the camera sensor in Isaac Sim. But then underneath that, you have the depth plus the segmentation mask. So this is something that has been performed by the UNet model, by the UNet network and the people model. And it gives you this like red sort of mask that you see for the human in that image is used separately to reconstruct the humans in the 3D mesh, which you see on the left side of the GIF over here. So again, this is just the walkthrough of how to actually set it up and run this whole example. This is something that you can just follow if you can install Isaac Sim and follow this example. Let's go to, this is interesting though. There is, if you want to know more about how human reconstruction works, see technical details. So we won't go through each of these, but there are like separate pages for most of these examples where you can read more in depth about what's going on and how it all actually works together. There's a whole kind of like a workflow over here about how the model, once given an input, how the model and the network generate the depth mask, the segmentation mask, and how that works together with the TSDF that we discussed earlier. And finally gives you a good reconstruction that you can use with NVBlox and visualize on RViz. So with this, I was just aiming to really go through some of the documentation for Isaac ROS Nvblox and show you how you can use the documentation here to go through each of the examples that you might want to create yourself and run. Okay, so there are some, I mentioned some parameters that we did not go through. So let's look at the ROS parameters. So here we go. There's a whole table of parameters and the default values that they use and a description of how they work. So it's a lot to go through, but of course, if you ever want to, if you're writing your own example and you want to set some of these to a more appropriate value, or you just want to experiment with what values give you the best performance for NVBlox, this is the place to go. So this contains the NVBlox parameters and then the actual parameters that are used while creating the map for mapping. This includes everything, like all the different modes, the static mode, dynamic objects, human reconstruction, all of the different modes that NVBlox provides, and a whole bunch of mapper parameters as well. To be honest, I have not experimented with all of these myself, but this is the most exhaustive way to learn more about them. Okay, so let's see what's left. Okay, so another important section, I think, if you're working with any of these examples and you're stuck, then I would suggest before jumping to create a post on the forum, you might find that a lot of your issues are already resolved here in the troubleshooting section. So let's go to some of these. Let's look at the Isaac Sim issues. These are just some of the common examples that we've also struggled with. So a good way would be to just go through these examples and then, of course, go to the developer forum, check if some person has already struggled through what you're struggling with. And if we've given a solution for that, you can feel free to try that out And if that does not work either, of course, the next best thing to do would be to just create your own post. Some of the real sense issues under troubleshooting, this is something I believe I have tried myself as well while running through the real sense examples. This gives a good explanation of how it actually works. So the real sense, from the real sense images, there is something called the splitter node. So this is again part of, you'll find the real sense splitter node on the Isaac ROS GitHub. It essentially splits your images and alternates between like the left and the right, so the infra 1 and the infra 2 camera, because we realize that that gives a better performance like while using with both vslam and nvblox. So it's a little like all the information as to why this is done and like how it works is given here in the troubleshooting section. And then there's also multiple checks that you can do. So if you notice that the images are not coming in at all through the camera, or that they are coming in and still not like generating something on the nvblox end, then I encourage you to go in this order. So under issues, you can find check number 1, and then if that is passing, then check number 2. If that is passing, you move on to check number 3, and then some solutions to what you can try. So this is a good way to, I think a lot of your questions and issues might just be resolved over here. So again, this is under the real sense issues and troubleshooting section of the Isaac ROS Nvblox quick start. So there's also, I do remember someone in the chat asking something about DDS. Let me see if I can find the question. Some robots do not use the ROS2 standard DDS. How do you deal with changes? So this is something else that we have experimented with and given some information in the troubleshooting again about like how you can tune DDS in case you're encountering issues with that, or how you can find the RTPS profile as well for Isaac ROS. And then that I believe you can also see the parameters set over there. Do remember that every time you make a change, though, you should restart the Docker container for those to apply. Okay, so we have about 5 to 10 minutes left. If anyone has any more questions, please feel free to leave them in the chat. For all questions that you may not be able to post today, you can do 2 things. You can either join the next Isaac ROS officers, which is next to next Wednesday, or you can create a forum post on the developer forum. And that should be either answered already or picked up within the next few weeks. Someone says DDS gets complex real fast. Agreed. Okay, so let's see. If we go back to Isaac ROS Nvblox overview, I wanted to just share some of the performance numbers here. So this is the performance table. It just shows some of the Nvblox core functions on different platforms. So we've tried it on the x86 and on the Jetson AGX Orin platform. And Replica and Redwood are 2 just public data sets on which Isaac ROS Nvblox can construct the 3D mesh. And so for this particular voxel size, 0.05, you can set this to the voxel size parameter, which I believe we discussed. These are just some of the speeds given to be able to reconstruct. So this table is especially helpful. There's also, I believe we have a performance summaries that is not unique to just Isaac ROS Nvblox, but to all the Isaac ROS packages that are out there. So this just gives a comparison of the different. Okay, before moving on, there's a question that says, do you have a link for the next meeting? Good question. I don't have a link right now, but the best place to find this would be to go to the Isaac ROS developer forum. Right at the top over there, there is, I believe, something that says Isaac ROS links and tips and hints or something like that. And once you click on that post by my colleague Rafaelo, you'll be able to find links to all of the Isaac ROS officers. So that would include not just the upcoming ones, but also the ones that we've had in the past. So you can go back and rewatch those as well. Yes, so I was talking about how you can compare the different performances on the multiple Jetson. These are just different Jetson platforms, AGX Orin, the Xavier, Orin Nano, and on an x86 machine as well. Let's see if we have Isaac ROS Nvblox over here. Maybe we don't, but we do have Isaac ROS Visual Slam somewhere. Yeah, the first one. So this is something because it's used hand in hand with Isaac ROS Nvblox. I'd encourage you to check out the Visual Slam node as well. Okay, my colleague has added a comment over here. I'm just going to share it on the screen. It says we'll be adding the next Isaac ROS office hours to the main event calendar soon. So this is a link where you can find it. Some people are already subscribed to the channel. That's awesome. Thank you. And thanks for joining again. So I am going to show you how to use the Isaac ROS Developer Forum and how you can find information there. Let's see. We have a couple of more minutes in case anyone has any last minute questions. Give me a minute while I look for the link. There we go. So this is the Isaac ROS Developer Forum that I mentioned earlier. Here you can find all of these questions that have been raised in the past by developers like yourself, and a lot of these, so you can filter these as well. So if there is something that you're struggling with, it's possible that we've seen it before and that we also have some potential solutions for you to try. So again, this would be the best place to start. If you do not find something related to what you're doing, please feel free to just start a new topic here, and we will get to it as soon as we can. If we've already, faced that issue ourselves, it's possible that we have some fixes for you to try. So going to the pinned topic here on top, it says Isaac ROS links, tips, and hints. So this is a good place to get started with. Just like we have some links to the documentation. Here you have the NVIDIA Isaac ROS office hours. So these are all the previous and current and upcoming ones actually. And then we also have a separate Isaac ROS webinar series. So we already have done a couple of webinars. You can rewatch these on demand. I think you just have to register for them with just your email and maybe company, I'm not sure. But then you can watch all of them. And these are like more long, maybe up to an hour, where they only talk about that particular topic. So unlike the office hours, which are more focused around questions and giving more importance and more time to questions, these webinars are purely for understanding the topic of the day. So that would be a great place to learn as well. Okay, there's a question that says, do you publish the office hour topics in advance? I believe we do. I'm not sure how much in advance we do it, but we'll try to be more, I guess, proactive about it. So we'll try to start publishing it maybe a week in advance or as soon as we've decided what the topic is. Also, if there are particular topics of interest related to Isaac ROS, where you'd like to learn more, then feel free to again leave a comment or something on the developer forum, and we can actually take into consideration those topics. Oh yeah, also feel free to write it in the chat. So you don't have to necessarily go and create a post. If there's something you'd like to learn about next, feel free to just let us know right here and we can start working on that. So one last thing before we have a couple of more minutes, I've just gone to the Isaac ROS webinar series page here. Give me a minute. Let's try presenting again. This is the Isaac ROS webinar series page. So this use your own CUDA ROS node. This was the most recent one. I believe it was in December. So we still have something upcoming. But here you can watch and you can register and watch all our on-demand content. So there is multiple. There's something about the nitrous bridge, Isaac ROS benchmarking, localization, object detection, visual slam. Again, one of the best places to learn more about each of these, apart from the documentation page itself. Okay, so I think that covers everything I wanted to share. Also, I think we covered most questions. But in case you feel like you didn't have time for your questions or that we didn't answer it in enough detail or clarity, please create a post. Again, the Isaac ROS Developer Forum, best place to go. Create a post there and we will look into it. Also, if you have any questions, say you're working on something and there are log files that you want to share, or there's a more like involved, you want to share the steps of how to reproduce, such that we can figure out, if something's going wrong. So those kind of more detailed questions are best on the developer forum, because while we may not have enough time to cover those in the office hours itself, the developer forum is some place where not just us but the community can help as well. So that would be the most appropriate place. Okay, so I think let's wrap up this week's Isaac ROS office hours with that. And I hope you register and do show up for the next one, which will be next Wednesday. Next to next Wednesday. The one next Wednesday will be Isaac Sim related. So again, anyone who has Isaac Sim questions, please go for the next Isaac Sim office hours as well. And thank you so much again for joining today. Hope you learned something about Isaac ROS Nvblox. And I hope for those of you, especially who have a Jetson or a RealSense camera or anything already, that you'll go and try our examples today. So thank you a lot and see you next time.